All right, so now we're going to look at lipids. Lipids include things like fats, oils, waxes. There are some vitamins that are considered lipids because they have similar properties as lipids, but we're not really going to get into that. You need to know that lipids consist of carbon, hydrogen, and very few oxygens. This is a major difference between carbohydrates and lipids, is this few oxygens. Remember, carbohydrates have just as many oxygens as as carbons, but lipids have very, very few oxygens. Okay. Lipids are also not considered polymers because they are not made up of repeating monomers, although they do have smaller subunits. The first subunit we're going to look at is glycerol. Now, I think that this word, glycerol, might make you think of glycogen from our carbohydrates video, but I don't want you to get them confused. Glycerol is part of the lipids group, and if it makes it any easier for you to remember, think of this arol. You've all heard of cholesterol. You usually think of somebody who eats a lot of fatty foods or might be overweight and have high cholesterol. So think of that arol, that ending, as part of lipids group. Glycerol has 3 places where other molecules can come and attach. You can picture it like a Lego piece. So the other part of lipids are fatty acids. So you can have a fatty acid attached to each of these connection parts, or each of these spots on glycerol. You can have a fatty acid at the top, in the middle. You can have a fatty acid at the bottom. Okay. Now, fatty acids can vary in length and in composition. Okay, and we'll look at some words that you've actually already been exposed to. You're familiar with them. You've probably used them and you just don't even realize what it really means. But let's look at that now. Okay. So the first is a saturated fatty acid. Saturated means that it's going to contain all of the hydrogens that it can possibly hold. So I'm only going to draw part of this fatty acid, but it has carbons attached to each other in a chain, so they are bonded to one another, and they're also bonded to hydrogens on both sides. Now, carbon, and we can just imagine that it continues on in both directions. Carbon can make 4 bonds. This is true of carbon always. So if you look at this carbon atom, you can see that it is bonded to a carbon here on this side, so that's one bond. A carbon here on this side, that's a second bond. And then it's bonded to a hydrogen here and a hydrogen here. This has 4 bonds. This one has 4 bonds. This one has 4 bonds. The fact that each of these carbons has 4 single bonds, all connected to something different, means that it is saturated. A fatty acid like this is straight. It really does look like a straight line, and they stack very neatly. So you can have these saturated fatty acids stacking one on top of another. This is what allows them to be solid at room temperature. RT is room temperature. So these are things like butter. If you leave butter out on the table, it can get soft, but it's still going to remain a solid. It's not going to be a liquid. The other one we'll look at is unsaturated. And there are different types of unsaturated fatty acids, but we'll look at that in just a second. Unsaturated means that there's going to be at least one carbon that does not have 4 single bonds. It still has 4 bonds, but not single bonds. Let me show you. So we could have a carbon here, carbon here, carbon, 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 carbon. We'll hydrogen, hydrogen. Here it's only going to be attached to 1 hydrogen, and this one will only be attached to 1 hydrogen. And then here we have hydrogens as well. So the fact that we don't have a hydrogen here and we don't have a hydrogen here means that this carbon only has 3 bonds and this one only has 3 bonds. That would not happen in nature what would happen is these two carbons would double bond. Okay? The thing about that is when that happens, this line, this chain of carbons does not stay in this nice, neat line. It would end up with a kink where that double bond is. So the fact that now you have this crooked line, this kinked line, means that it doesn't stack very well. I mean, think about trying to stack a bunch of curvy things that really have curves in different places. It's not going to stack very easily. This is why unsaturated fatty acids are liquid at room temperature. So that's things like oils. So your olive oil that hopefully you use a lot of because it's very good for you is an unsaturated fatty acid. Now, there's also things called monounsaturated fatty acids or polyunsaturated fatty acids. In this case, you should be using your prefixes. You know what mono and poly mean. This is a monounsaturated fatty acid. It only has one double bond. A polyunsaturated fatty acid might have a double bond in several different spots. Now realize that this is a very short chain. Fatty acids can actually extend up to 20 or 30 carbons. So it could be that there are several spots, several kinks, or several locations where there is a double bond. Okay? Keep in mind that saturated fatty acids, if you have many of those, you're going to have a solid at room temperature because they stack neatly. An unsaturated fatty acid is going to be oil at room temperature because they do not stack very neatly. And remember that these fatty acids are connected to that glycerol backbone. Okay. All right, so one of the things that you need to make sure you remember is that lipids are hydrophobic. We talked about that. We talked about that with properties of water, and I have it in the video with properties of water, but it's just worth reminding you. They are hydrophobic. They do not like water. This is water fearing, meaning they really just want to be away from the water. Okay? This is particularly important when we talk about the structure of a cell and especially the cell membrane. So I'm only going to give you that little teaser right now. We're not going to get into that right now, though. The major functions of lipids, this is the most important part, is these functions of lipids, functions of carbohydrates. That's what we really want to get at. The first one is long-term energy storage. Lipids actually contain a lot of energy in them, so whenever we eat fats, it provides us with a lot of calories, but we'll go into calorie contribution of macromolecules later. First, you just need to know that lipids provide long-term energy storage. So while carbohydrates give us that quick energy, if we are doing anything that requires a lot of energy, a long output of energy, then we'll first use up those carbohydrates, but then we're going to start using our lipids. That's why if you're trying to lose weight for some reason, then you have to exercise for probably longer periods of time, so that first you use up those carbohydrates and then you start using lipids, using those fats. We also talked about a function being insulation. Okay, somebody who has more lipids as part of their body is going to stay warmer more easily than others who, are a lot thinner. Remember, animals that have a lot of fat or blubber, they have a lot of insulation. That's a lot of lipids as part of their body. And finally, we have waterproof barriers or membranes. So this is what we'll talk about when we get into the cell membrane and start talking about that. But a really cool thing about this waterproof barrier, think about waxes. Okay, if you get water on a candle, it'll probably just drip down. There's a really cool thing about some plants, particularly in the desert, that have on their surface a waxy coat. particularly the surface of a leaf. So they'll have a waxy coat, and remember that in the desert they're not getting a lot of water, but sometimes it gets really cool at night, and the water or any moisture that's in the air might collect on the leaf in little tiny droplets. That's called dew. But since those leaves have a waxy coating, that those droplets are more likely to slide off, because remember, water and lipids don't mix. They don't like each other. So those water droplets will slide off and go down to the roots. And that is exactly where a plant needs the water, because from the roots it can then draw the water into its body. So that's just a neat little piece of information about lipids and how they, how waterproof barriers can really help them be very functional for a plant or other organisms as well, but we'll get into that later on. That's it for lipids. Look out for the next video where we'll talk about proteins.